Hello, welcome back. Today we're going to be talking about solving linear systems by elimination. The objective is that by the end of this video, you should be able to solve linear systems using elimination. One definition of elimination is the act of removing or getting rid of something. So when we solve by elimination, you just need to know that we're going to be getting rid of something in the act. We're now going to solve the following linear system using elimination. We look at this, we have two equations, and both equations are written in standard form, ax plus by equals c. So, in other words, notice how our x's are lined up, then our y's, then our equal signs, and then a constant on the other side of the equation. That's an important setup for using elimination. Now, the way elimination works is we're actually going to take both of these equations and we're going to combine them together to make a third new equation. So, on the left-hand side of our equal signs, we're going to combine our x terms. 3x plus 2x gives us 5x. Then we combine our y terms. Negative 2y plus 2y is 0y. Equal to 12 plus 18 is 30. Then we divide both sides by 5, and we get x is equal to 6. The reason this worked out so nicely is our y terms canceled each other out or were eliminated. That's why they call this using elimination, because when we add our two equations together, one of the variables should be gotten rid of or should be eliminated. Well, now that we have the value of x, we can solve for the value of y just like we did in substitution by substituting that value of x back into one of the equations. This gives us 3 times 6 minus 2y equals 12. So 18 minus 2y equals 12. We can subtract 18 from both sides. And we get negative 2y equal to negative 6. Divide both sides by negative 2. And we get y is equal to a positive 3. Leaving us with, in the end, a positive 6 and a positive 3 for our solution. Just like when we were doing substitution, we now need to check our solution. So I ask that you go ahead and take 6 and 3 and substitute it back into both equations to make sure that it is indeed a solution. I substituted 6,3 into both of the equations and worked it out and found out that 6,3 did give us a true equation for both of our linear equations. So that means that 6,3 is indeed our solution. Solve this following linear system on your own, pressing pause. When you're ready to see the answer, please press play. When I worked it out, I got negative 7, negative 4 as my solution to the linear system. What we're going to do next is I'm going to go ahead and check my solution. So again, you go ahead and press pause and press play when you're ready to see the check. And when I checked my solution into both equations, I found out that it was true, so negative 7, negative 4 is indeed our solution to the linear system. Suppose we're asked to solve this linear system by elimination. Looking at it, you might notice that, well, everything's already lined up, so you might think, well, let's go and add everything together. But 3x and the 2x gives us 5x, negative 5y gives us negative 10y, equal to 12 plus 8 is 20. Immediately, we can see that not one of the letters was eliminated, so we cannot use elimination immediately with this system. So what we're going to have to do is we're going to have to multiply one of the equations by a negative 1, so that one of the y's will be a negative 5y and the other one will have a positive 5y. It doesn't matter which one we choose, I'm going to choose the top one. So, when I distribute negative 1 to that top equation, it gives me negative 3x, negative 1 to the negative 5 gives me plus 5y, and the negative 1 to the positive 12 gives me minus 12. So, I'm done with the first equation and I've multiplied it by negative 1. Now, when I combine my two equations, negative 3x, positive 2x gives me negative x, positive 5y, negative 5y, they cancel out, equals negative 12 plus 8, which is negative 4. Notice that I've now eliminated the y's, and I can continue solving for the x. So I get x is equal to positive 4. I can substitute that positive 4 back into either of the original equations. So I always just choose the top one, so it gives me 3 times 4 minus 5y equal to 12. 3 times 4 is 12. Minus 5y equal 12. Subtract 12 from both sides, and I get negative 5y equal to 0. Divide both sides by negative 5. 0 over negative 5 is just 0. So my solution should be 4, 0. Now, as usual, we need to check our solution, so go ahead and press pause. Check your solution, and when ready to see the answer, please press play. And my solution checked out. Go ahead and try to solve this linear system on your own. Before you get started, notice that none of the variables will be eliminated as you start. The 3x and the 3x, that's positive 6x. 2y, negative 4y gives you negative 2y. So you're going to have to multiply one of the equations by negative 1. Again, it's your choice. Go ahead and press pause, work it out, press play when you're ready to see the answer. I chose to multiply the top equation by negative 1, and then when I added my two new equations together, I've got negative 6y equals 6, divided both sides by negative 6, I got y equals negative 1. I then need to put that negative 1 into either of the original equations. And when I solved it out, I got 8/3, negative 1 as my solution. Yes, it's okay to have a fraction as a solution so long as it checks out. So I'm going to go ahead and check this out by substituting it into both equations, and hopefully it'll give us a true statement for both equations. Go ahead and press pause, try to work it out on your own, and press play when you're ready to see the answer. And when I substituted it in, I found out that it was indeed a solution to the linear system. Note that when you multiply a whole number times a fraction, you need to put that whole number over 1, and then you multiply the tops to tops and bottoms to bottoms. Then I divided 24 over 3, gave me 8. 8 minus 2 was 6, and 6 equals 6, so that one checked out. And it was a similar process for the other equation. And to finish up the video, go ahead and try to solve these two on your own, pressing pause, and when you're ready to see the answer, please press play. I had to multiply the top equation by negative 1, and then add both the equations together, give me 0 equals negative 7. Notice when all of the variables are eliminated, you're left with nothing or 0 on that side of the equation. So 0 equals negative 7 is not true, so we know that there is no solution. For the other one, when we were solving, we noticed that we got nothing on the left-hand side and nothing on the right, or 0 equals 0, which is a true statement, so there are infinite solutions to that second system. Remember what no solution looks like on a graph? This is just a reminder. No solution looks like two parallel lines that never intersect. And infinite solutions would be one line right on top of another. It's a good thing to keep in mind as we're working through these visually or graphically what these two situations look like.